Hey guys, welcome back to Max TV. And no, this is not my brand new background picture for my workbench. It is part of our project. So today we'll be having a look at how to make illuminated 3D sign. Not really a sign, more a decor for your home. A while back, I was renovating Mama's bathroom and we've put a skylight in, solar skylight, so it's actually electronic. And that's when I came up with this idea. So let's have a look at it. This is the exact skylight by Kimberly. It's called Illume. So it comes with a solar panel and this skylight. It uses the same technology as an LCD panels. So let's open it up and have a look inside first. It's 24 volts. I will plug it in for I'll plug it in for you first. It comes with a driver. Here's a LED driver. Now this will only work, that project will only work with the flat ones like that. So see how they're very, very flat. The reason why the normal LED light probably wouldn't work as well. It'll work, but not as good as those ones, because those ones are exactly the same as LCD panels without the panel on the top. So the light is very even. Let's plug it in and have a look. It's supposed to be consuming 660 milliamps at 24 volts. You can get similar ones like this ones from your local hardware store, eBay. They're very cheap to buy. You can get a square ones, different sizes, circle ones, 12 volts, 5 volts, any voltage, and you can actually modify them if you want to. So let's power this one on. And yes, very, very bright, as you can see, and it's natural white. I'm not sure if camera is capturing it right, but as you can see, the light is very even. There's no spots anywhere on it. So I'll turn that off because it is very bright. Actually, if I'll cover it, that's a cardboard, and yeah, cardboard just covers it well. But yeah, let's pull it apart, see what's inside first, and then we'll install the picture into it. So anyway, before we open it up, I'll quickly show you the pictures. So we're all familiar with those 3D pictures on the plastic. You can get them from $2 store for $1 probably. I've got a few here. It's really hard to capture them without the light, but as you can see, it's 3D. There's another one that we will be using. Yeah, you can see that it's the image in 3D. It doesn't look as good on the camera, but it does look really good in person. So let's get those out of the way. Let's open it up and see the structure of it. So it's really easy to open it up. They clip on the wall, so they're very easy to swap. Again, because they meant to be solar, if you're buying just the powered one, you can still buy a solar panel or attach it to a small solar panel and stick it on the roof to make it as a skylight. So the top ring unclips, and what we'll find inside is pretty much same structure as the normal LCD panel. We've got the diffusing plate, just a simple diffusing plate. Underneath we have a glass. That's what the usually LED panels use, or LCD panels. It is just a perspex glass with the white dots etched onto it, so when the light illuminates it from the sides, those dots light up. I'll see if I can actually show you that without the diffuser. Let's plug it in again. So yeah, there we go. It starts glowing at 18 volts, and you can see those dots. Let me get that closer to the camera. Those dots are illuminated, and that's what's giving the even light. So once we remove that, we have an LED strip. This is a very small LED strip. It's probably 4 millimeters, if not 3, with a small LEDs. The ones you buy on eBay, they use a standard 50/50 LED strip, so you can put any one inside. You can put the color one, you can put RGB, you name it. So let's put this glass back in, and let's put that in. That all clips on. So with that ring off, now we have access to it. And what I'm going to do, using that picture, I have already marked the circle. Again, if you're buying a square one, it could be square, it could be just, any picture. You can buy small lights and you can have just one part of the picture, and you can make multiple lights out of that 3D thing. So I've already marked the circle. I'm going to cut it out and fit it in. Okay, so that's been cut out. I've still got some left, so I might use this for small panels that I have from broken LCDs and make that into something. So I'll leave that. Here's the circle, and there's just a thing to note. That ring that you've just cut out, it's not fully going to be displayed. There is about 10 millimeters on the edge that is covered by the ring itself. So once it goes inside, as you can see, there is still some spots covered. So before you cut it, make sure you know what's in a picture. So that kind of a buffer of 10 millimeters on the edge is going to be hidden away. So it happens that it slides in perfectly. It's got just the right amount of space to slide that in there and clip that on. You can use a little bit of a sticky tape if you don't want it to move. If it's a circle light, as you can see, it rotates, so you can just have a little bit of tape on each end. Again, it's not going to be visible because that side is covered. So just a little bit of tape to make sure it stays in place, although it doesn't matter because you can always rotate it. And let's clip the ring back on. So that's been clipped in. As you can see, it's actually quite good effect on this angle. Let's plug it in and see what it looks like. Now this is only powered again from 18 volts, so let me turn the lights off and see if it'll be better without the lights. It looks awesome. Let me try turning away the other video lights. They are bright. And that's mounted on the wall. You can buy something like a sky. Let me put it at full brightness. Again, full brightness, it probably will blind the camera, but we'll give it a go anyway. Where's the voltage? So this is at full power. And to me, that looks really good. On the camera, it does look washed out, but in person, it does look quite well. Let's see if I can return the lights, and that will maybe... No, it is still too bright. But that looks very, very good. Again, you can buy different sizes and fit them. So, by the way, with this large picture, it is very large. Very, very big. It's... yeah, it doesn't even fit on my desk. I'm thinking of buying a huge light and fitting it in there. So here you can see originally installed skylight, solar panel powered skylight with that picture that I've installed with the dolphins. I think it's time to upgrade it. It looks pretty good, but let's put the picture that we've made at my bench in. The lights are very easy to remove. You simply just pull it out of the wall. It's held by the clips in the back. Unplug the power connector and the light is removed. Then you just plug the new light in, align the clips, put them back in, push it in, and it's done, and it looks great. Just as a bonus, let's have a look what's hiding inside the driver. So the solar panel is directly connected to this input. There is nothing else. It's direct solar in, and that's output straight to LEDs. There's no other electronics in it. It's time to have a look what's inside the driver. And what do we have here? So on the input, it goes to a capacitor, which is 50 volts, 220 microfarad. It goes through the diode, a couple of resistors, what looks like a controller. Let me see. This is WS 3215. Then it goes on to inductor and another 220 volt 220 microfarad 50 volt capacitor, and it goes straight to the LEDs. So I found the datasheet on the WS3215 chip. It's actually a very interesting chip. So it's the 40 volt 1.5 amp step down high brightness LED driver. It's the features are simple low parts count, wide input range, voltage range from 8 volts to 40 volts, output current limit protection, and it even has a dimming function, not in this driver. In this driver it doesn't have it. I actually reversed engineered. We'll have a look at the schematic in a second. So this applications for it is MR16, LED lights, automotive lights, low voltage industrial lighting, illuminated signs, which is technically what we have. So let's have a look at the example schematic that they include. As you can see, it does have the dimming pin, which can be operated either with a pulse width modulation or just voltage. So they're suggesting a bridge rectifier, AC 12 to 18 volts with a bridge rectifier, or DC 8 to 40 volts. It goes through a 100 microfarad capacitor into the chip, 0.13 ohms resistor, 60 microhenry inductor, diode, and 3-watt LED. So here's an internal circuit if you're wondering. So that's the chip, and that's the internal working diagram if you want to pause and have a look at it later. So here's the reverse engineered schematic that I've made. It's a bit crooked, that's alright. So we've got 8 to 40 volts coming in. It's going past the 220 microfarad 50 volt capacitor straight to the chip. Those pins are Schottky, I believe it's a Schottky diode, right across them. Also, and the center pins are both common to negative. So also the positive goes through 3 resistors, which I assume were tuned. Let me get the light better. So I assume they were tuned specifically for this LED light. It's in parallel 2.2 ohms, so 22 ohms and 39 ohms. From there, the line going straight past the capacitor to LEDs, and the other one is coming out of the chip, going through 47 microhenry inductor, past that capacitor again, and straight to LEDs. And they used 7 LEDs in series, and there is a chain of them in parallel. I didn't count the chain. So that's a very simple circuit, and I assume that empty pin can be used as the dimming device. So that's what's inside this LED driver. Very interesting driver. Thanks for watching this video. I hope you got some great ideas from this content. There will be heaps more of videos like this to come. Your support is very important for my channel, so please subscribe and like the videos. If you have any ideas for me to try or experiment with, please comment below. I will see you next time. Bye.